Welcome to the ENFUSE module on environmental monitoring with sensors. This module will connect, using some very common sensors, concepts from your circuits class to real-world systems that are helping us better understand the environments all around us. An area of great interest and one expected to see major growth in the coming years is the Internet of Things. This certainly is a buzzword, but as illustrated in this figure, the idea is that everyday devices can now be connected to exchange data and information that will allow them to operate more effectively and efficiently. One example would be wireless sensor networks that are made up of many small embedded devices that communicate sense data and give us insight into the environment in which they are deployed. Applications might include monitoring of natural habitats to better understand flora and fauna, environmental conditions in buildings, for example, temperature, light, humidity, or even aerosol percentages, so that they may operate more efficiently and safely, as in a smart home. Or vibrations on vehicles and machinery to better understand when maintenance needs need to be performed. Applications for the Internet of Things also include systems that allow patients to move around untethered at home, but still get their vitals to doctors, so-called telemedicine, and systems that enable precision agriculture that controls the application of water and chemicals as a function of what is observed in the environment. In all these scenarios, there is some sensing that occurs, and the devices that enable the sensing are the focus of this module. A sensor, which often consists of several components, converts some physical phenomenon, for example temperature, force, or acceleration, to a measurable signal. That is, a voltage that is proportional either directly or inversely to the phenomenon of interest. Sensors have some aspect or some component whose electrical behavior, that is, resistance, inductance, or capacitance, varies with the phenomenon of interest. But to produce a signal, the sensors will have additional circuitry to condition the signal so as to produce an output that is a variable voltage. In this slide, we see a component called a photoresistor, whose resistance is dependent on the incident light intensity. We also see a light sensor that integrates a photoresistor into its circuitry, along with other components for signal conditioning, to, in the end, produce a voltage at these pins that are proportional to the light intensity. Sensors enable us to get information from the environment, and their dual is called an actuator, which is a device that can change the environment. Example actuators include lights, heaters, speakers, and motors. Sensors and actuators work together to ensure any influence on the environment or system is controlled. As an example, we see a linear actuator that enables systems to move components in one axis, so either out or in. In the next slide, we'll see how this actuator, combined with a sensor, might be used to create a useful system. The scenario here is we are using a light sensor to determine whether sun is shining at the sensor location, and then using an embedded system, such as this Arduino, to determine how a linear actuator might move. The operation of the system is such that the phenomenon of interest, specifically sunlight, changes an electrical parameter of a component, specifically the resistance of that photoresistor. The conditioning circuitry on the sensor board produces a change in the voltage at the output of the board. That output is fed to the Arduino, specifically to its analog to digital converter. That digital data is fed into the microcontroller, and the code running on the Arduino determines what to write to the digital analog output of the board. And then that output is fed to the linear actuator, thereby moving it up or down, that is, either in or out of the shade, depending on how the code's written. Applications for this type of circuit might include a sun-seeking system that could be used to move a solar panel so that it's always directed towards the sun. In contrast, a shade-seeking system could be used to automate blinds in a house. In this module, we'll discuss several types of sensors, and we'll present circuits used to condition their outputs. We'll leverage concepts from circuits such as Ohm's law, voltage dividers, and current dividers, and we'll focus on three types of resistive sensors: the thermistor, the photoresistor, and strain gauges. And we'll show how these devices can be utilized to instrument and monitor the environments around us.